everyone, my name is Cameron McKenzie. I'm an applications engineer here at Man & Machine, and today we're going to be looking at the manufacturing capabilities inside of Fusion 360. So for those of you that might be new to Fusion 360, it is Autodesk's cloud-based design and manufacturing product, which allows a platform to go right from the concept phase all the way through to manufacturing your components, whether they be parts, whether they be full assemblies, whether your team be located in one single office off of one single laptop, or whether you be a multidisciplinary company in multiple locations and collaborating across multiple sites. It is an all-inclusive package that will allow us to go right from the beginning all the way to manufacturing our products. Because Fusion 360 is cloud-based, we've got the ability to, as I say, work from anywhere we want to in the world, really. As long as you've got an internet connection and a computer, you've essentially got the ability to do some work within Fusion 360, which is a really beneficial selling point to going for Fusion 360. Today we are going to be looking at the manufacturing capabilities inside of this and hoping to show you the benefits of A, working in the cloud, and B, just the sheer number of tools that are available inside of Fusion 360. So without any further ado, I'm going to go straight into this. I've chosen a fairly simple model, it isn't going to be the most complex model. We're not going to do super complex machining or manufacturing in this particular instance, but it's really just a case of having a look at the different capabilities that we have inside of Fusion 360. So I am inside of the design environment where you would be doing most of your design work. And I'm looking at the moment at an assembly. We can see all of the individual components that are listed inside of this. We've got two stand legs, a tray, and some bolts tying it all together. We've got the ability to have these components either inside of the assembly, as you would with most standard design packages, and as individual components, individual parts on their own. So I've got a stand leg over here. In the design environment, we can see the overall component and how it looks on its own. Each of these items have their own capabilities and their own benefits, obviously, on their own. And some of those then are the ability we have now to create, manufacture these particular components. So I've got my stand leg over here, and I've got a tray that will sit on top of that particular leg, and that's what creates our assembly over here. So today I'm going to be looking at how we would manufacture each of those individual parts. So looking at the stand leg, this is in our case, a plastic part. We would potentially want to go and either machine this out of a solid piece of plastic, or we're going to be looking at today the ability to use the additive manufacturing process inside of Fusion 360 to actually 3D print this particular model. So going to the manufacturing environment inside of Fusion 360 is as simple as changing the workspace. We design inside of the design workspace, and we manufacture inside of the manufacturing workspace. So just switching to the manufacturing workspace, you'll notice that my toolbar or ribbon up at the top has new buttons, new tools available to me for this particular workspace. At the top, we've got milling and turning, which will be our subtractive manufacturing options. We've got additive, which will be the 3D printing. We've also got the ability to do inspection and fabrication as well, which we'll get into a little later on. So for this particular part, what we would want to do, I've already got a completed version over here, which we can roll back to at a later point. But essentially what we wanted to do inside of Fusion 360 with the simplified interface is we're generally working from left to right in order to go through our either design or manufacture or any other of the workspaces that we have. So the first thing we want to do is go in and create a setup. This will start to tell Fusion how we're wanting to manufacture this particular component, including the machine that we're wanting to use to print this off. Sorry, this has gone onto my other screen. Let me bring it on here. So whichever machine we're wanting to use to print our component, whether it be one that's in our current library or whether it be inside of Fusion 360's library as well. I'll just go for a generic Autodesk one. and I'll just go for an FFF on this particular one. This part I've designed as a ABS plastic, but we'll just use this anyway. Go and grab that, okay this, and you can see in the background it's showing me the bed that it's going to be using to print our model. We can then also choose the print settings. This is where we would go in and adjust exactly how our item is going to print. I can go and edit this if I wanted to, or export this if I wanted to. And yeah, go in and adjust exactly how we're wanting to print this, down to the infill, down to the thickness of the outer layer. And all of that is being driven by our print setting library. We also then got the ability to do some arrangement inside of the workspace. So it'll take the volume of the bed, the volume of the area that will be used for printing, and align and orientate our model inside of that area. So we can have it that it does an automatic arrangement as well. I'm going to leave that unticked for now because I want to adjust that myself and set that myself a little later on. Once we're happy with that, we can hit OK, and it will then go and place that in. And you can see at the moment it's highlighting it in red, telling me that it doesn't quite fit inside of my environment or inside of my printing bed. So I can go and position this using the different positioning tools and get it more or less where I'm wanting it to be located. Now, because this is going to be having some vertical strain going onto it with the pressure of the laptop or whatever device you're putting onto the stand, I'm going to want to print it in the current orientation so that the layers and the lamination of it is in the correct orientation. So I want to print it on its side as it is currently. So I'm happy with the current orientation of it. Perhaps I could rotate it around as well using the dials on the side over here. If I can grab a grip of it from this angle, you can see we can rotate this in any direction. We can use the arrows to move its positioning, and we can use the squares to rotate it, or move it rather, in a plane, so in two directions at once. Once we're happy with the positioning of this, we could use other options to analyze the printing themselves, whether we're wanting to minimize the build height to have it as low as possible, or whether we want to ensure that the parts themselves are placed directly onto the bed. We've got the ability to use that inside of the positioning options. We've also got the ability to enable and adjust the supports that are generated for this particular component. So if we did want it ever so slightly up or above the bed itself, just by hitting enter on this and confirming the movement, I can go in and add in some solid volume supports to the bottom of my component to make sure that the entire component is supported during this process. We can change the overhang angles. We've got the ability to avoid certain surfaces and ensure that there's a certain distance to other supports as well if we wanted. We've got the ability in the General tab for the volumetric supports to set the top distance and bottom distance of the part as well. That'll then go off and generate that and consider the geometry as part of this process, and then create a solid support underneath the structure, which will then be considered during the printing process. We've also got the ability, if we wanted to have solid bar supports, and this is if you didn't want the supports themselves to go straight from right below your component into your component, but rather wanted them to come in at a bit of an angle to avoid touching other surfaces. If we were to have designed this or wanted this part printed at a 90-degree angle, so it was vertical, we might not want the supports to go through these surfaces if they are a high finished surface, and we want the supports to then go in from the side instead. But in this case, we've got the orientation that I'm wanting. Once we're happy with this positioning and the supports that are created as part of this process, we could then go through and generate our toolpath. So I can right click on my additive toolpath here, generate it, and it'll run through the generation process where it's going to calculate layer by layer how it's going to want to print our component. I've already got another setup finished and calculated, so I'm going to head over to the active one over here, although it looks like this one has completed in time, so I'm just going to go and stick with this one then. And we've got the ability, after we've generated these, to actually simulate the toolpath. So I can go into the simulation option. And from inside of our simulation environment, we can then go and see layer by layer how this product is going to be printed. We can use the little timeline down at the bottom to skip to certain positions. You can see over here building the supports. So anything that's highlighted in light blue is a support. Then we can start to go through some of the infill, the outer layers, and the inner layer of our component. As we go further up, you can see the infill is being populated. As I zoom a little further out of this, we can see then as well that the holes that have been placed inside of the component are getting some supports generated in for them as well. And as we go all the way through, we then get a representation of what it's doing at every single layer. Got a little indicator down at the bottom over here telling us what layer we're at and how tall the component will be at this particular point in time as well. All the way right to the end where we've got a finished component, all nice and 3D printed from here. The next component we're going to have a look at is the tray that would sit on top of this. Now, for this particular demonstration, I'm going to manufacture this using a CAM process. So we've got the additive manufacturing, which we've used for any 3D printing, but we've also got the ability to use subtractive manufacturing or CAM milling, whether it be turning or milling or mill turn as well. We've got the capabilities of inside of Fusion. Now, this isn't a be-all and end-all of a demonstration of the capabilities of Fusion, but this is a really good indication as to what it is capable of as well. So again, using our end-to-end product lifecycle, we've gone from designing inside of the design environment to actually then going and manufacturing inside of our manufacturing environment. So we'll switch from the design workspace to the manufacturing workspace to then begin to create a finished tool path. Again, I've created my own one over here, but I'll go through the process involved in making these as well. So again, we would need to create a setup for this. Inside of the setup, we can then assign a machine that you're going to be using to create this component. Again, I've gone for a generic Autodesk one, but we've got the ability using the select over here to go through an entire range of or an entire library of machines that we can go and grab. So if I filter my list just for milling, you can see the various machines we can go and use. You might see, if you are a manufacturer, some of the machines that you might be using day to day. We've got the ability to filter via vendor, and you can see a large library of vendors available to us, and Autodesk and Fusion team are always adding to this, which is really great to see from a manufacturer's perspective, that there is that engagement between Autodesk and the vendors themselves. They are always continually updating and ensuring that we've got the correct posts for our machines. And as you can see, they're supplying us with beautiful models of the machines as well, which we can use during the simulation process. Again, as I say, I'm going to go for a generic Autodesk one on this one, but we do have the ability to go and select a machine from this library, and 99% of those machines will also have posts associated to them. So by choosing the correct machine, we then have the correct post associated to that as well, which makes the whole post-processing phase that much easier as well. If I close this off over here very quickly, you can see similar options to what we had before inside of the additive, but we've got a few slightly varying options inside here as well. And that is the orientation of the model. So if you had designed your model with a different orientation to what you wanted to manufacture it in, we've got the ability to override that orientation. And we've also got the ability to use different models inside of our component, so we can turn certain features on or off during the process. So if we just wanted to have a model without any of the holes on the inside and just look at the overall perimeter of the part, we've got the ability to do that as well, and have different manufacturing models based on the phase in which we are machining our components. We then also go and choose the stock. So the stock that we choose can be either fixed size or relative size box, cylinder, or tube. So depending on the the shape and size of the stock that you're using, we can come in and grab those from here. If I had to go and choose a relative size box, it'll take into consideration the size of my component and then add a little bit of stock on either side, top, bottom, and then round that up to a nearest value, giving us the stock dimensions down at the bottom as well. If we were using and wanting to simulate this inside of our machine, we could go and choose the positioning of our part inside of the machine that we've selected. So this is where picking that machine in the setup makes really good advances in the ability to go and run through the simulation process. If you do have multiple components next to each other inside of your setup, we can then see how they would be in relation to each other and where they fit inside of the overall bed that we're using to manufacture this particular product. We can then move it, and it'll take into consideration the positioning of this in relation to our origin point. I'm not going to adjust any of this. I'm going to leave everything as is on this particular one and just hit OK on there. Now, once we've got that set, we've now got a bit of stock and we've got a component that we wanted to take out of this. So we've got inside of our manufacturing environment, and specifically the milling environment, we've got our toolpaths split into 3 separate groups, I suppose technically 4. We've got our 2D options, and these will require a 2D input of any sort, whether it be a perimeter of your component, whether it be a sketch that you've sketched out or drawn out inside of Fusion 360. And we can essentially go and take the geometry from that 2D input, and Fusion will use that to drive the toolpath that we then go and assign. So if I had to go in and grab a 2D contour, for instance, I can go in and say that I want to go in and choose the 5mm flat, which is a tool that I've selected over here, and I want it to go all the way along the perimeter, which is just a 2D input of the item itself. I could change the tool as well. Again, we've got an entire tool library available to us in the same way that we have a machine library available to us, either a generic Fusion 360 library, or we've got the ability to create our own local or cloud-based library as well. So if you do have your own library of tools that you want to add into Fusion, so that it always takes those into consideration when manufacturing your products, we've got the ability to grab those there. And we've also got the ability to download vendor libraries as well. So if there is a particular vendor on that list that you want to grab their entire library from, we do have the capability to push that straight into Fusion 360 as well. I'm just going to choose this 5mm flat end mill as part of this process. And you can see it's picked up, based on the tool that I've chosen, the various speeds and feeds of this particular tool. To go over to the geometry tab, I've got the ability to go in and choose a 2D representation of what I'm wanting to machine. So because this is the contour, I choose the outside perimeter of this part, so I can go and grab that bottom edge over there. And as soon as I hit OK on this, it's going to go through and generate a toolpath going all the way around the outside of that particular component based on my selection. We've also got some 3D manufacturing options or 3D strategies available to us. So the 3D strategies will take into consideration the overall 3D part. So if you have created anything with slightly more complex geometry that just a normal 2D sketch won't be able to take into consideration, we do have the 3D options. And as long as you've designed your component in the 3D aspect to the exact representation of the finished product, we've got the ability to tell Fusion that it needs to machine anywhere that isn't the designed part. It'll get rid of any stock that exists outside of our designed component. So those are the 2 main areas inside of the milling environment. We've also got drilling options available to us, either standard drilling, or if we are using the manufacturing extension, we do have a hole recognition tool that's available to us, which will automatically go in and find holes of varying sizes for us. So in this case, we've got a fairly simple pattern of the same size, and you can see that inside of our hole recognition toolpath, it's automatically picked up 2 different hole types as well for us. As soon as we're happy with that, we can go in and go and tell it which tools to make use of. It'll go and look for tools that work best for the component that or the holes that we've selected. We can go and create hole groups, so we can either tell it to use a different strategy for each individual hole type or hole diameter, or any group that might be created as part of this process. And if we were to go and say we want to go and create a spot drill and tap blind hole, we could then tell it what the thread would need to be on that particular item as well. But if I go and tell it to do a simple drill on any 12mm hole and the 15mm, I think it's actually the 15mm that I need in this case, and I'm going to tell it to ignore any 12mm in this particular case. Although it's telling me that there are only 4. So I suspect I've done this the wrong way around. Let me ignore the 15 and go for the 12. It helps if I know the part that I've designed. There we go. So you can see at the bottom right, the holes that have been recognized and the holes that are going to be machined are 148. So it's already picked them up nice and quickly for us there. As soon as I hit OK on there now, it's going to run through and using the options that we've given it, go and create a toolpath for every single one of those holes that it has recognized inside of this component, really making that design process and the manufacturing process that much easier by going right the way through our product. Now we could go in again and create a 2D contour on the inside to get this beautiful Man and Machine logo cut out of the component, and use any other machining strategies in the holes as well. And yeah, really go to town with adding in the strategies, making sure that we're getting as much of the component in as possible. I mentioned the manufacturing extension earlier, so that gives us the capability to use this hole recognition tool. We've also got other options available inside of the whole within the manufacturing extension, which are the ability to trim toolpaths and delete passes, and there really is a lot of great additional functionality that we can use inside of the manufacturing extension. The other big portion that includes is the ability to use multi-axis strategies. So anytime we are doing anything more than 2+3 strategies, if we're using 4-axis or 5-axis, we've got the ability to make use of the full capabilities of our machines using the multi-axis strategies. Not only do we have the swarfing, multi-axis contouring, and rotary, but inside of our 3D strategies, when we are machining fairly complex geometry, each of these strategies have the ability to enable multi-axis functionality. So we can tell Fusion to use a certain primary alignment or angle for our spindle when machining during this particular strategy, or we could tell it to align to or from a particular point inside of our environment, or a curve inside of our environment as well. If I go through and quickly activate my original setup here, it's got a bit more work to it. We've got the hole recognition tool, which has gone in and done a few drills, as well as the contouring over there. If I cancel out of here very quickly and just activate this one. We can then go and run through a simulation of this environment as well, or these toolpaths as a whole. So similar to what we've done inside of the additive environment, we can do the same inside of our subtractive manufacturing. So grabbing the entire setup over here, including all of the toolpaths, we can actually go into our actions panel and just say we want to simulate the overall process. You can see the simulation environment that it gives is fairly similar to what we had inside of the additive. We've got the ability to play through this, or we can grab the timeline down at the bottom and watch it go through every single individual hole inside of our part. Go and machine that hole by hole, and then run around the outside for the final contouring finish. We've got the ability to change how this is displayed, so whether we're wanting the stock displayed or not. whether we're wanting the toolpaths displayed during this time or not as well, and how much of the tool and other environments we want to look at as well. We've got the ability to do some section analysis during the simulation process and a few other tools and tricks available as well. So a really great way before we even begin manufacturing these, just to make sure that we are going and getting as much of the material out as we need during the particular process. Once we've gone through the process and are happy with the toolpaths that we've generated, we can then go and post these out. So again, as I said right in the beginning, we've got inside of our setup, we've already told Fusion which machines we're wanting to use, and those machines each have their own posts associated to them. So if we had to go and post-process this, we're essentially converting all of the toolpaths that Fusion has created into the relevant G-code. In the post-process options, you can see we can use the machine from the configuration. We can choose a separate post if the post that we're wanting isn't the correct one. We can give this a number, a file name, commenting, tell it where to post this to, whether it be a local drive or network drive or wherever we're wanting to push this to. We can also keep this saved as a file inside of Fusion 360 if we needed to, and point that to a team folder if we wanted to as well. So if you are collaborating with other designers, perhaps your machinists are in another workspace or even another area, another site, you've got the ability to post this to a central database where your machinist can go and grab this from. In the Operations tab, we've got the ability, if we ever needed to disable certain toolpaths as well. So if we didn't want to, at this time, use any of the drill operations, particularly potentially the spot drill, and just wanted to do actually both spot drills, we only wanted to drill all the way through and not do any spotting, we've got the ability to disable those as part of this process. Once we're happy with that, we essentially just post this out and it'll generate the code based on the post processor. The last environment I want to take you through in this particular instance is the ability we have to create fabrication models as well. So if I go and grab this model over here, it's not in any way related to our stand assembly, but with this particular item, we've got a few panels that are of the same size that have created this cabinet. Now, this cabinet could have been created in another program and brought into Fusion 360, or this can be designed inside of Fusion 360, and we want to then create a fabrication model of this, where we want to flat pack this, or create a machining profile to be able to create to laser cut out the profiles, the parts themselves in this case. What this will need is these individual items to be solids or components inside of Fusion 360. And once they are, we've got the ability to tell Fusion the alignment that we want for our particular component. So knowing what Fusion does about the items and the timber sheets that we might have available to us, we can go into our utilities at this point in time and decide how we're wanting to nest these components. So in the Utilities tab, still within the design environment, we've got the ability to do some preparation before we go into fabrication itself. And in the nesting options, we've got the ability to choose the alignment of the grain on all of our individual components. So we've got this next preparation window that appears for us. So from here we can tell it to either ignore certain elements that exist inside of our assembly, or we can keep them in as they are. So it's automatically going to go grab sketches and or selected entities as well. So each of these individual items are one of the components that exist inside of our assembly. And what we can do from this is tell it various items, whether we want to change the extrusion direction, whether we want to calculate the thickness automatically, which it's done in this case. Otherwise, we can tell it a thickness that is associated to this particular item if it isn't the same size as has been designed in this process. We've also got the ability at any point to go and choose the direction of the grain that might be required as part of this process. So if we are wanting to ensure that it is enduring certain vertical or horizontal loads, we've got the ability to change the alignment to make sure that the grain best aligns with the particular item. And we can choose that for every single solid that we have inside of our assembly. Once we're happy with that, we can then go over again to the manufacturing environment for this particular item. And rather than using either milling, additive, or turning environment, we want to go and grab the fabrication environment. This one's already gone and created one for us, but if we wanted to use a new one, we've got the ability to go and create a new nest study as part of this process. So we can go in, add any comments to this, say how many jobs we want to produce as part of this, how many stacks we want, or what the stack size is. We've also then got the ability to input inside of our library the various source sizes. So we've got different sizes of panels that we can go and tell Fusion to look for and calculate which are best for the components that we're wanting to create. And then we can tell it how we're wanting to package these as well. So once we've got all of those inputs set, it's then going to go in and take all of the components that exist inside of our design environment, all of the components from the assembly, and it's going to go and generate a setup and model orientation for us on those. So if I go and activate this now, you'll see that inside of this, it's gone and created multiple manufacturing models, each for individual sheets. So how these individual sheets will be nested as part of the process. And we can then take each one of these sheets and create toolpaths and cutting paths to be able to manufacture this particular product. So you can see we've got nest 3 over here, and then the other study I just created now would have been sheet 6, but that's because I only selected the one item mistakenly. So we've got our study over here, which will allow us to go and grab each of these individual components. If we wanted to, we could then go again through the process of creating a setup for that. Again, I've created my own one over here, so I'm just going to go and grab that. And inside of the setup, we can go and choose which nesting study we're using as part of the setup, basically choosing different manufacturing models. And you can see how it then goes through and selects those ones and adds them into the environment for us. Once we've decided on the one that we wanted to use as part of the study, we can then go and hit OK on there. Ignore the warnings. Famous last words. There we go. And we've got the ability then to go and create a 2D profile that is then cut out as part of this process. So it's simply a case of adding a strategy to this, telling it which profiles we're wanting to use. And if I just right click and generate this, it's going to go and calculate the toolpath that is required for this particular component. Let me edit this one and reselect the geometry. So we can go in and grab the contours of a particular component, grab each of those faces. This one has some fairly complex geometry, as you can see over here. So what we might want to do instead is go and grab our silhouettes of the component. And you can see all of a sudden it has gone and grabbed the silhouettes of those. So we can either go and say we want all of the loops, which will include the holes. So if you did have certain holes that you wanted manufactured, which in this case we want that one over there selected. Otherwise we can say only the outer loops, which will ignore any inner loops and only create the outer, or we can say only the inner loops and it'll only select the inner loops as well. So really great selection process available to us. As soon as I hit OK on there now, it's going to go, OK once more, it's going to go and calculate the toolpath required for that, and it will then go and cut out the components. If we still wanted to, we could go in and add any other toolpaths to this. If we wanted to go into the milling environment and add milling to machine out any of the other areas as well, but you would likely want to have that as part of a separate operation. This is just using a laser cutter. Again, once we're happy with all of this, we've got the ability to go and use or go and post this out as well if we ever needed to, using our post-processing, and we can push this out as a final finished G code for our machine. And that's essentially an overview of the manufacturing capabilities inside of Fusion 360. We do have a few other environments that are available as well, including turning, as well as inspection, which the Fusion are continually adding capabilities to as well. But really hope that this has been a good overview for you if you are considering looking at Fusion 360. As always, if you do have any questions regarding any particular functionality, please do get into touch with us. But other than that, thank you very much for your time today, and have a great day further. Bye.